All right, so let's get started just by showing you some of the parameters around the railings. I think I have a deck here for you. It's here, yeah. All right, railings, it's a system family. As a system family, it's a definition that can only be created within the project context. You cannot save a railing as an external file. But it's a special type of family, similar to the curtain walls, because it's a system family that is made of loadable components. And so a railing, it's made of, as a system family, can be created by duplicating the existing one, the basic default one, and then replace the information about it. A lot of the railing parameters are type parameters that define what is the distribution of the different posts, the distribution of the railings in the horizontal, and the distribution of the balusters. So a post is it's a representation of a railing post. It's a solid created using solid editor. But there are three types of posts when you build a railing. You have the start post, which is the post that you see right at the beginning of a railing flight. You have the end post, which is the one you see at the end of a railing flight or a stair flight. And then you have the corner post. The corner post, the ones that happens at the change of the railing direction. And a lot of those definitions are built into the type properties of a railing. Posts are typically done using extrusions or revolves, and they define the start, the end, and the corner points of railing path. The other type of family are the horizontal members, the rails. And the rails are two-dimensional profiles extruded along the length of the rail. They can happen at different heights. You can customize the profile, you can customize the height. And usually there is a built-in rail definition that is special, I would call it. Those are the rails that help for handrail supports, the ADA handrail supports, the one that stick 3 inches away from the line of the railing. And you can build those definitions also in the type property of a railing. And then we have the baluster families, which are the infill panels that span between the posts. A baluster can be a post family. It could be also a panel. And then you can create creative combinations of panel and post in order to define the infill material between the first post and the last post. The dialog box of the stairs has changed a lot over the years. But this dialog box, which is the baluster placement definition of a railing, it's a little scary, but it's not after you understand everything that goes there. It has basically it's divided in two: the main pattern definition and the pose definition. We can start with the pose because that's the easy one. The start pose is the pose that's placed at the beginning of the railing length. So if this was your point number 1 and this is your point number 2 when you create a railing, so this is the family that is called start pose, and then this one here is the end pose. And then if there is a change in direction, a change in direction is when the railing sketch lines create new segments at the end of each segment. Then it will place a corner pose. And all these families can be the same, like in this example. Well, they have exactly the same definition. Host is usually the work plane that the stair is hosted, and a base offset just defines an offset from that host. And then the top is it's a work plane. It's called railing. This is a work plane as well. And a top offset, we need to move it up. And then the next part is the main pattern, and the main pattern explains what is the elements that infill the distance between the posts. And in this particular example, it's just a baluster that it's placed at a host work plane with a railing, a top profile. This is top profile. And distance between the balusters every 4 inches. An offset is an offset from the vertical plane of the railing. So if you're looking at if this is post number 1 and this is post number 2, this is the vertical work plane. So the offset is, if it's negative or positive, how much from the vertical plane the railing moves away from the placement plane. This is the justifications. There are 4 choices. You have when you justify a pattern of when you justify patterns of balusters, there's going to be a residual space that Revit needs to understand what to do. And so when the center choice, it split in half the residual distance. The start, it places a residual distance from at the beginning of the end is towards the end, and spread to fit, it just distribute evenly the number of offsets, the number of baluster, up to the minimum defined in the distance value. And so in this case, when you do spread to fit, the size of the baluster is going to change. It's not going to remain fixed, but it's going to expand a little bit to let you work without any baluster filler. Let's see. There's another thing called here.
Hi, Cesar.
Yes. Do you have a question?
Oh, sorry. I had problems with my computer, so I couldn't get on earlier. Sorry.
Oh, no problem. Okay. Break pattern is It has to do with the amount, at what point the formula identify a change of direction. You know, when there is a change of direction, actually, no, the corner post is that. The corner post is where do we tell the formula to place a corner post? Each segment end is the default. That means every time there's a change in the direction. But you can also say a specify angle. And what that means is that a corner post is only going to be placed in the drawing if it's up to a certain angle. So yes, let's learn how to do one from scratch. I'm gonna just open one example and then show you the rest. Or let me show you, here are some graphics. This is the corner post, each segment end. That means that every change of the railing direction. Never means that when there are changes of direction, there's no posts at all. And then at angles greater than, it means that this is a floor plan, a schematic representation of the sketch line. So if the change of direction is greater of a certain degree, then place the post. So this is a condition based off an angle, the angle between the first sketch and the second. All right, and here's this, what's the space. It's controls the location of an offset from the center line. Let's see, I think I have, and then these are stairs, I think. Yeah. Oh no, these are properties of the railings to allow you to create different type of railing connections. Sometimes these railing connections are mathematically impossible inside Revit. And Revit has to do these Gus-Duck connections. And your choices to fill these conditions is you can have no connections in which there will be gaps. You can add vertical and horizontal segments with the trim connections. Trim connection is that each segment of a rail abuts the other one. And then add vertical and segments with weld connection. Weld is that they are trim at 45 degrees or whatever the angle is. Using weld connection. I think this number C is usually the one that looks more elegant in the project. This is other types of railing properties. Angle joins means in a single flight, you can have no connections between the vertical change of direction, not the horizontal one. You can add vertical and horizontal trim with the trim connections, or this is the ones I like the most. This is the extend to meet, which is a tangent joint. This allows to really smooth connection. The connections, trim or weld, those are the two choices. All right, this is some of the some custom railings that clients have developed and that I've come across. These are really cool. There's a lot of flexibility if you know how to build them properly. Okay, so let's go into Revit and let's bring just one of the railings that are available in out of the box. So under the architectural tab, I am on level 1. You sketch the path of a railing. You have to use the draw tools to build your sketch. And out of the box, Revit comes with 5 different families. Let's do the glass panel. I'm going to do first click and then second click, and then do another segment. The distance doesn't matter that much. I just want you to see what happens when you have different type of line types. And I have an arc. So again, I'm doing sketch lines, architecture, go to architecture, and then a railing. And the type I chose was glass panel bottom fill. And create a segment that has a change in that in floor plan, and a round one, a round arc. Click the green checkbox. I'm going to switch to 3D view and switch the display to shaded, which enable this. And this is an example of a custom glass panel that it's following the rules defined by the editor, by the railing editor. Okay, there are a few things that I don't like about this railing. At first, you see how the justification is it's set to split center. So the residual filler is divided in half. But that's something, and if you encounter that, that's something that you can easily fix. I'm gonna edit this and make the change. So you edit the type property of this railing glass panel bottom fill. And then go to the baluster placement. And notice how the justification, it says center. But you can change this to spread pattern to fit. And then hit apply. And hit OK. And now that it's taken care of. Now I don't have that any filler panel or excess panel anymore. Another thing I want you to notice is that circular railing or circular panel are very difficult to model. Like these, notice how this panel doesn't curve, but notice how the intermediate railing, they do curve. And so one of the tricks in order to make a curved panel is to actually make a railing that has the profile of a panel, and make it a glass material. So in other words, instead of right now, this is a baluster family, and this is a post family. And these are the railing profiles. So in order to make this curve, one of the tricks that you could use is that instead of using a baluster panel here, you create a railing profile that it's curved. So then it's gonna The railings are they follow the line of the they are extruded along the path of the railing. And so in that case, you will have to use a different type of, I have to replace this with a different profile. All right, I want to continue discussing this. There are a couple of new parameters in railings that came with that have come over the years and that haven't been exposed very often with customers. So when you select this railing and you access the type properties, notice that there is a section of railing construction that is called the top rail, the handrail 1, and the handrail 2. So the top rail is the profile definition for the crown rail. So in other words, it's a definition of these family. This elliptical 1.5 or 1/8, it's this profile. The overall height is 3 feet. And if you enable that, then you're basically turning this profile on. Then we have others that are not in use, but we could. We have handrail 1 and handrail 2. So notice that when you create a railing, this was point number 1 and this was point number 2. The railings have also direction. The location of the double arrow indicates what's the exterior side of the railing and what is the interior side. And so railing 1 is the railing that associated with a railing on the exterior side. So that is a railing, a handrail for access support. And then handrail 2, it's a handrail in the interior side. And right now those options are off. But say that the city is requiring us to provide a railing at a height of 2'8". And so you select a type. This is the handrail type, and it's asking you for a lot of type properties. For example, how are the segments connected, either fillet or metered? What is the hand clearance? That's the offset from the center line. What is its height? What is the profile? What kind of transition it has? What kind of material? And then it has something called extensions. And these extensions have been evolved over time. There are handrail extensions that goes that takes the shape of a post, or maybe they turn into the wall or they turn into the floor. So post means that it's going to have an extension of a certain dimension. Let's say if we're trying to follow code, 1 feet. And then the extension style at the top, it's also a post with a length of 1. And terminations are ways in which you support the rail. And terminations are families as well. I don't think I have examples here for that, but usually when you have a stair that is hooked to the wall, then it has support terminations. All right, so all I'm doing, I added these extension styles, and then hit apply, hit OK. And you know, I didn't see that coming. Oh, position. I have to put position to the left, to the right. There you go. And maybe the top rail, it's 42 inches instead of 3 feet. We have a guardrail with one of the handrails, 2 inches away from the center rail. Let me show you the other options. You select this railing, edit the type. I'll go to the handrail number 1, edit the type using these 3 little dots. And the extension style here, it's the post. And I say, okay, this is going to be, let's change it to a floor one. Click apply. And now instead of sending the post to the turn to the railing, is actually send it to the floor. Or you can send it to the wall. And you see it only turns, it will turn to the left. Or none, it just switch it off. I'm going to leave it as a post. Apply, okay. And you see there's another consideration. There's an option here that says plus thread depth, which is usually if this railing was to be used in stairs, you can add that code requirement. The bottom of a railing needs to have the 1 foot extension. I mean, that's a few of the things that stick with me with the ARE. And there's one at the beginning, and then at the top. Beginning is when you start a railing. Okay, so you apply, okay. And again, that rule only was going to happen when I place this on top of a stair. All right, and then handrail 2 is another variation. You also have the option to add another handrail. I'll go back to the top rail definition. No, this is good. The top rail definition is fine. I'll go back to the circular type handrail 1. Notice that Revit also has a choice here that's called, what is it? These are the handrails. No, let's see. Oh, here, position, my bad. You can have it left and right. Here's the type properties of the, and what I'm doing is, it's doing it in both sides, left and right. Now, in addition to that, I can have another handrail if I needed to. But this is a little bit redundant. And what left and right, again, it depends on what is the exterior side and interior side of the railing. Okay, so let me explain some of the properties of the baluster. So again, I selected and edited type, and under the railing structure, there are 2 railings defined in this one, rail 1 and rail 2. So rail 1 is this guy right here. And then rail 2 is this guy here. Maybe the 3D view doesn't let it see very clearly, but it's behind the handrail. And one is at a height of 2'4", and the other is at the height of 2'8". And those can be changed. You know, since I increased this by 6, I'm going to make this 3 feet, and the other one at 3'4". The railing cannot be higher than the top rail. All right, I made a change of that and make it a little tighter at the top. Okay, but I wanted to build a something that is completely from scratch, and let's do that. Any question about these parameters? Let me explain a little bit about these baluster placement rules. I show them in the deck, but let's look at that right now. I want to create something similar. I'm going to select the railing, edit the type properties, and let's look at the rail baluster placement. So I think these are pretty straightforward. Let's do the ones at the pause at the beginning. So let me do a 2 segment here. I'm going to do texture, stair, not railing. Okay, I'm in the baluster rules. So start post 1 is the profile use or the baluster family use for the first post. And that is this guy here. The end post is the last one. So that is this guy. And then the corner post is this corner post. Every time there is a change in direction, then place that family. And place that family at each segment end. What that means is that every time there's a change of direction, you can do that. If you change it to never, then that corner is not going to be there. Let's leave it at each segment end. And then the space, you see how it has a positive and a negative thing. That 1/8 of an inch, it's when you look at the the space is a vertical offset from the center of the rail. So notice how these the vertical posts and the glass, they are a little offset. They're probably offset by 1/8 of an inch. And that's controlled by that property. It's how far. I think they're trying to mimic the location of the panel. Okay, let's go back to these baluster placements. And then the baluster family. That's this steel flat profile. This is a place. Here you go. This is that profile. And then we have and notice how it said distance from previous is what is the distance between the end of the glass panel and the next baluster. So right now it says 0. So what means that at the beginning of each of the railings, you're going to find that element. And then notice the distance between is 1'4". So the distance between panels, it's 1'4". Okay, so let's assemble one from scratch. I was just running some of the type properties. Oh, before I forget, the railings, you can access the path if you want to do something completely custom. For example, this is not the type of extension that you had in mind for a particular case. So you can tab, select the railing, and these only work with the definition handrail. It doesn't work with like the balusters of the post. So you hover over, tab, select the railing, and then you edit the rail. This gives you access to the extrusion path, and you can select the extrusion, and you can edit the path. When you edit the path, you're actually accessing the extrusion segments, the sketch lines, and say that instead of being a square meter, you wanted to have some fillet. So I'm going to say, make this a radius of 2 inches instead of a hard edge. And I take the first segment. Oh, here is edit rail joins, where it says edit rail joins. I thought I could just start changing this. These lines. Let's see if I add more segments. The path. Oh. Trying to make this curves. It's not letting me do it.
If you select the what you're doing, the fillet, you didn't click the radius tool. Go ahead, select that. Click the radius and click 2 inches. Now click one segment and then the other. It should do it. Oh, it didn't?
It doesn't, yeah, it doesn't let me. I don't know.
Oh,
I don't know if it's working on your end.
it is working on my end.
It's
Let
the
me,
path, right? You
now let me try again. Try.
edit the path.
So edit rail. edit path. You have to be in 3D, by the way, right?
Yeah, I am in 3D.
Okay.
So hover over,
Yes.
tab, edit the rail,
Yes.
and then edit the path.
Yes.
This should be
Click the fillet tool. Yep.
radius.
Yep. Make it bigger. Make it 6-inch. Just exaggerate it and see. Click one segment. Oh, it's not allowing you to click it, huh?
Yeah, it's odd. If it's working on your end, awesome. If not, there must be something on. This is a bug. In my opinion, this should be working, right? Because I can't even add a straight segments. It's not snapping. Like I should be able to 3D snap to the end of this. And
How about if you cancel and reset the configuration? Okay. Now reset, or see that on the right, all the way to the right, reset. And then try it now. See what happens.
you know, maybe it's because I think this is my guess. I think I don't have to. I need to disable the handrail definitions and then add them manually because it seems like it's trying to force this post. So I'm going to set this to no, I'm going to select this, edit the type, and disable the handrail. Not here.
Do you have to be on 3D? It didn't work for me on 3D, but if I'm on like an elevation, it works.
Oh, really? Let's try that. I'm going to do a straight segment of a railing. Then I'm going to switch to the south elevation. Select this, edit type, use the left, and tab select, edit rail, edit path, line. Oh, now it works. Yep, you were right. Thanks. And let's see if I can do the fill. It doesn't work in 3D. It works in 2D for me as well. And then you can customize the kind of extension for the beginning or the end of a post. Thanks for the tip. And you can do the same for the top railing. You select it, you edit the rail. Again, I'll have to be in elevation, I think. And then you can edit the path and add additional segment lines. I don't know, for some reason you want to do something like this. Finish. And then I just customized the top railing to do something else. And so, but the railing condition, the top rail and the handrails are not accessed via the baluster formula. These are individually added families in the different stair work planes. All right, so let's make a one railing from scratch. I just shared some tips on how to edit the handrails without accessing the post. One of the drawbacks of doing this manually, maybe is fine for unique conditions, but if you're gonna have this typical condition everywhere, maybe it's better to build a post and then add the post and the balustrade distribution, because you don't wanna be doing this extension manually over and over repeated times. Okay, I'm gonna delete this guy and let's do one from scratch. And for that, I'm going to use always a baseline. And the baseline here, I'm going to do a sketch path. And this time, instead of using the glass panel bottom fill, I'm just going to do the simple handrail rectangular, the ugly one that is by default. And I always complain that this one, it's users build the stairs and they leave this by default. And these are hideous. These are horrible rails. I don't like them. And I always find myself changing new projects. All right, and so to create a new definitions, we're going to edit the type properties, duplicate, rename, and change parameter values. They're rules for creating new types. So select the railing, edit the type, duplicate it. I'm going to call this handrail custom. Hit OK. Then hit OK here. All right, so we're going to do one with just a custom post. We're going to build a custom post, sort of like a colonnade of, it's like sort of like a classical type of railing that has this sort of colonial distribution of posts every couple of feet and one vertical railing. And so to get started, I mean, all those families need to be loaded into the project in order to assemble them. So I'm going to close all the views. I'm just going to leave the 3D view visible in the project. And I'm going to create a new family, And the template I'm going to choose, look into the English Imperial. And then select the edit baluster post. The baluster post family comes preloaded with a lot of work planes that are pre-baked to help you define it and build it. So this is the left elevation. We usually build it on the left or on the right elevation. These work plane here represent the overall baluster height. So we should keep that on the in mind. That is the baluster height. And then this one here is the top of the post. So usually you build it all the way to the top of the post. And so I'm going to sketch what we're going to do. We're going to create a new profile. We're going to create a revolve. And it's going to have this sort of classical way of doing posts. So we're going to have something like this, an arc. like a chess type of baluster. And then this is going to revolve 360 degrees. And we're going to snap it with the top of the post rail work plane. Remember, these heights, the baluster height and the top of the post, are managed by the family definition. So those are flexible. You may want to create or snap your sketch lines to these work planes if you want them to adapt to the host as well. So, okay, so I am in the left elevation of these post family, and let's go and create a revolve. Create a revolve. It's going to ask for a working plane. The working plane is a reference plane, left, right. And I am now sketching in the left work plane elevation. We can do the axis line first. That's very easy. Axis line, it's the center of the post. I made it a little bigger than the extent, but it's clear. And then we can do boundary lines. And remember, in a sketch line, you have 2 rules. The sketch line must be closed. Sketch line in a closed loop. And sketch lines cannot overlap. And as long as you follow those 2 rules, the sketch line is going to work. If not, Revit is going to get angry and say that it cannot continue. All right, we're placing boundary lines using lines. So I'm going to start from the bottom, the intersection of the work plane, and I'm going to go, let's say, 4 inches out on the X. Then I'm going to do like a couple of inches, like 2 inches here, 1.5 inches on the right. And I'm going to do a 3-point arc and snap point here and do something like that. Again, you feel free to design your own. You don't have to do exactly like I'm doing here. Then I'm going to do like 1 inch towards the right. Oops. Straight line. Then straight here and straight there. That's my boring profile. I also need to close the loop. So make sure that I do the last segment like that. I'll give you a minute. Just create a profile that you like. I mean, I could have done more stuff here. Let me see if I can do something quickly here. This is the midpoint and or a line from the midpoint here. And I could do something like 3-point arc from here. Then from here. And then fillet. I'm doing arcs. And then that what you like, use your imagination here. Just keep proportion and keep in mind that this is going to be twice the size when it's revolving. So if this is 4 inches, the total thing is going to be 8 inches. So it's like a big column. Once the profile is closed, you can click the green checkbox. Then you can switch to 3D view to check how it looks. That is my post. And I just snap it to the top of the rail. So if the toe post stretches, that's what's going to happen. So think about that, because sometimes the host has something different. I mean, the default height here is 3 feet, I think. Yeah, it's 3 feet to 11.5 inch. I know what that half inch come from. But that is the height of the post. If this was like a corner condition where you want it to be like a monumental corner or start posts, then you definitely need to do this higher. In fact, I think I'm going to make this. I want to make this 3 feet even. So you just select top of the post, and I select 3 foot. 3'6". I'm going to do 3'6". And that's the shape of the baluster. Hopefully your design was better than mine. Okay, so I'm going to save this file, save as a family, and let's place it in a folder that you can retrieve easily. I'm going to put it on my desktop under, I have a railing folder here. And I'm going to call this classic post. And then I'm going to save it. So this is the first part of this is the first family that I'm going to do there. And then the other one I'm going to do is that these classical posts is going to be connected by a profile, a custom profile that is like a 3 by 1.5 or 2 by 4 profile. And that is a profile that I need to build as a profile family so that it can be nested in a rail. So I'm going to get started by creating a custom profile. So I go to new family. And in the English Imperial, you pick look into the profile one, and there's one that is called profile rail. Don't use the other types because there are profile for mullions, hosted, reveals. It has to be profile rail because that's a subcategory that needs to be associated with the rail inside the railing families. And then hit open. One of the characteristics of profile families is that they are two-dimensional. Notice how the 3D view is not visible. You can only draw two-dimensional lines. And these lines are hosted by the reference plane, reference level. This is the center line. This is the rail top. And so the rail top is what's driving the location of the railing. So if I want something that it's 2 by 4, it has to be, this should be the top and this is the center line. So I'm going to create a rectangle of 4 lines. So create a line and then use the rectangular tool. And it's going to be about 4 inches by 2. You can make it circular as well if you want. I just decided to do rectangular. And then you snap to the top of the rail because that's how the formula is going to place it. The railing also can be placed at the center of the profile, but it's up to you because this is a top rail I'm using. I'm going to snap it this way. I want the top to be associated with the rail top. And notice here in the profile usage, you can go back and change. These are all the different type of profiles. Mullion, reveal, slab edge, metal deck, noising, riser, supports, wall foundation sweeps. You access these drop-down lists only if you're going to make a profile for those system families. And so, for example, if you want to create a custom mullion, you have to switch this profile use to mullions so that it's associated with the right type parameters. There's no need to build any parametricity around this unless you want to create like a system of families of railings of this shape, but I'm just going to leave it like that. And I'm going to save this family, and I'm going to call this classic profile. That is the custom railing. All right, and now it's just a matter of assembling, getting it all together. So I have the posts, I have the railing, and let's see. Yeah, let's build a baluster. I was thinking first without balusters, but I think I have time. We have time to do a quick baluster. And it's going to be super simple. It's going to be like two diagonals snapping to the baluster corners. All right, so let's create a baluster family. You go File, New, Family. Now the type of family you want to use is now the baluster panel, and then hit Open. All right, so you're presented with the left working plane of the baluster panel. And if this rail is going to be used in stairs, then the work planes you need to use are these guys here. The sketch line need to snap. When you create a extrusion, the sketch line needs to snap to those working planes. This slope angle is a variable condition defined by the stair host. I mean, that angle changes from stairs to stair depending on what's the configuration. I think for the default ADA type stair is 32.47 degrees, but it could change. If the baluster panel is not going to be used in stairs, then it's okay just to use it. Is it always going to be flat? I think it's okay to use this for reference plane. So we're going to assume this is not going to be used for stairs. So let's go simple with that. What we're going to do, we're going to create a diagonal from here to here and a diagonal from here to here. And it's going to have a circle as a profile, 2-inch circle. So what we're going to do here is we're going to use a sweep and a profile, a circular profile that use that diagonal as a sweep path. So I'm going to go slow because these are several steps and I don't want you to miss. So you start by creating the sweep. So there are two parts in the sweep operation. First, that you create the path. What is the path that profile is gonna travel? And then you build the profile. And the profile is something that you can pick from a drop-down list, or you can edit the profile on the fly. So we're gonna edit the profile on the fly. So every time you sketch a path or sketch a profile, you have to click the green checkbox to exit that operation. So this is the sweeps are funny because you have a sketch mode for the main command, and then you have two different sketch mode for building the sketch path and building the profile. So you have to exit the sketch path of each of them in order to exit the modify sweep sketch mode. All right, let's do part number 1. Sketch the path. It's asking for a work plane. The work plane should be left. So pick the center, left, right. Hit OK. And now I'm going to snap to the intersections, SI, snap intersection. And a snap intersection here. So that is the path of the first segment. I'm going to finish creating the path. That is what this green checkbox is. You notice that there's also a red dot that indicates the origin of the profile and the work plane host that will host the profile sketch line. So I hit the green checkbox here. The sketch path is defined. Now let's edit the profile. In the profile section, then now it's activated. You click edit profile. We're gonna do it in 3D. Yeah, it's easier to do it in 3D. And then in the center of this dot, you do a circle that it's about 1 inch. 0.1 inch. Is a 2-inch diameter, 2. Then hit the green checkbox. And then hit the green checkbox again to finish the sweep. And that is the first part of the sweep. All right, this should flex by if you change the width, let's say to 3. Notice flexing the family works. So no matter what's the size of the baluster defined by the host, this is going to flex as expected. I'm going to leave this in 3. Now let's repeat the same for the opposite diagonal. So you go create, again, a sweep. The first part of the sweep is to edit the sketch. So click the sketch path in the ribbon. Choose as a working plane, choose the left, right, center, left, right. Hit OK. And use a line that snaps to the intersection of this reference plane, goes to the opposite end. Click the green checkbox to finish the path. The path is ready. Now I need to add the profile. So the profile will be done by sketch on the drawing. So you added the profile. I'm going to switch to a 3D view because it's easier to build it there. And then create a circle. Make sure it snaps to the point. And I have 0 to 0 to, that's it 2, yeah. And then hit the green checkbox. Actually, it's 1. So to go back, I edit the sweep, select the circle, edit the profile. I'm going to change the circle to be 1 inch in diameter. Hit the green checkbox. And there you go. That's how it renders. And then let's flex it. If the width is 2 feet, this should change 1 feet, changes. I want to leave it in 3 feet. It also changes when the baluster height is different. You see, baluster height is 2'6", baluster height 3 feet. Okay, so I'm going to save this baluster. And I'm going to call it also classic baluster. I'm going to save it. And I have all the components ready. Now I just need to load them into the project and assemble them into a single rail definition. So I'm going to close all the families that I have open here. I'm going to close the posts. And I'm going to go, I'm just going to stick with the project that has the custom handrail. And I need to load the loadable profile, the loadable post, and the loadable baluster, and then assemble them in the type definitions. So you go to the Insert tab, Load Family, and bring those 3 components that we just created. I save them on their desktop, on their railing. And I'm going to bring the classic profile, the classic post, and the classic baluster in a single step. Those are going to make them available under the families, under the railing category. So under the railing category, you see the classic baluster, classic post, and the the top rail. Oh, and the other baluster is going to be under profiles. Under profiles. Here's classic profile. So they're distributed in different categories. This is the classic profile on the profile category. We're going to use that for the top post. And then the railings, under the railing category, you have the classic baluster and the classic post as a single type. All right, let's assemble them. You select, I can't change this definition because I already duplicated. I call it custom handrail custom. All I need to do is to access the type properties. So I'm going to edit the type. I'm going to start with the railing structure. So go back and open the railing structure. And these are all the horizontal members of the railing. So I'm going to insert a new rail. And the profile I'm going to use here is the classic profile. Notice that it's in the middle of these choices because the subcategory that this is associated is railing for handrails. So I use the classic profile, and the height is going to be 3 foot. You can give it a new name as well. Like this is a top rail. You can assign materials here. I'm going to skip materials for the meantime. I'm going to apply this top rail. And it should be there. You see, this is the custom profile that that we built, and it's extruded along the rail. Again, I'm going to repeat it very quickly. You select the railing. This is already duplicated, you know, edit type, duplicate, rename. I did that to create a new type. Then you edit the type properties and hit the rail structure, the one that says non-continuous. And then I inserted a new rail definition. I put it at a height of 3'0", and it has a classic profile as a profile definition that what we created in the previous exercise. And then it's placed at a height of 3 foot from the base. And this is what you get. The other thing I'm going to do is select. There are 2 overlapping rails here. I need to get rid of one of them. So select the railing definition, edit the type, and notice how I'm going to not use the top rail definition. Just hit apply. Notice that everything disappeared except the this rail condition, and that's fine. So sometimes you have the options of build the railing as a top rail or embed it into the rail structure. You can do either. In fact, you know, let me see if I can use this as a classic. Yeah. Let's leave it without a top rail, and if it doesn't work, we'll come back and create associated instead of embedding it in the rail structure, I can embed it as a top rail definition. Okay, so let's go into the hard part, which is the baluster placement. So here I'm going to start with the second half, the posts. So at the start of the post, I just want the classical one. So classic baluster. And I'm going to put the same for all of them. Classic baluster. Sorry, classic post, no classic baluster, that's the other one. Classic post, we're talking about the post here. And it's going to start from the host, and it's going to extend to the top rail. And then leave the rest as is. And hit OK, hit OK. and I have the first and the last one. And I also have the corner post. So you go architecture, just to test, I'm gonna do a railing that has a corner post. And then change this to the custom. There you go. All right, now let's put the balusters. So you select the railing, edit the type. Now let's go into the baluster placement. The baluster placement is we're gonna do two. The classic post is one, and I'm gonna add another one, insert or duplicate it. The other one is the classic baluster. So one is the post, and another is the baluster. And I'm gonna space it every. The first one is gonna be at 0 distance from the previous, and then the other one is gonna be 4 feet away. So that means the classic post is gonna be aligned with the edge of one of them, and then the other is gonna be placed every 4 feet. So again, I have the classic post and the classic baluster in the same dialog box. Hit apply, hit OK. And nothing happened. Why that? Oh, let's see, base, top rail. I think I need to specify the top rail here. Okay, almost there. The zero post means that I need to change the dimension.
Yeah.
Yeah, so in the baluster placement, what it was happening is that you say 0, it's at the center of the baluster. That's basically what it means. So I can say instead of 4, make it 2. There it is. Oh no, I think it's 0 is the offset. Yeah. Every one. Let's see. It's getting angry. 0. Okay. Fine. Okay. I thought with 2 would be enough, but it's not doing it. I don't understand why it's not doing this. So from 0 to top rail, distance from previous 0 every 4 feet. Let me do this every 2 feet. Okay.
If you set it distance from previous 2 feet and then 2 feet for both, it gets pretty close.
Oh yeah. Yeah, exactly. That's what I wanted to do. Thanks.
Welcome.
All right, and now let's get rid of that profile, the filler. So if you go back to baluster placement and in the justify, say spread to fit, hit apply, hit OK. Didn't do it. I thought it would do that. Apparently it's not doing it. It's not spreading to fit. Supposed to do that, but it's not getting rid of this. Have to get back to you on that one because I typically, when it's just a solid panel, it works. I leave that center, but let me do another, create one from scratch, create similar. Yeah. So I'll get back to you guys as far as what happened with the with the residual panels. Typically, it's no problem. It would do it, but it's not doing it for some reason. Maybe we missed a lock or something in the baluster creation family. Let's see. There's a file that I think I want to share with you guys. It's I know that railings take time. You see, we almost spent an hour just doing it. But I have this railing definition, maybe you have already, which has a collection of railings that far exceed what you find out of the box. This is called a type catalog or a type container, because railings cannot be saved as separate RFA files. A smart way of collecting them and distributing inside firms is to build this type containers. So you should have a type container for like wall types, for railing types, for floor types, and then have the user access as read-only resources that he can pull, copy to the clipboard and paste. And these are examples of all different type of railing definitions. I mean, this is sort of what we were trying to do here. I'm just going to investigate. Yeah, two different profiles, and one is one has a 0 and 400 millimeters. This is in millimeters. So I don't know. I'm going to investigate why the spread to fit is not working. But I'll put this in the Google Drive if you guys want it as a reference. But one of the things I want to recommend to use railings for is to use fences, like a railing in Revit 2024. You can snap railings to topo surfaces finally, and you would be able to like build a fence that follow a topo surface. And then this is an example. This is another like classical example. This is more like for, you know, all San Francisco type of baluster of configuration. And this is just a colonial baluster. And then Newell post at the beginning and at the end. And they all snap to rail 1, which is what we were doing. Let me show you another example. I think some railings can also be used for, yeah, this type of fencing. And this is a smart way of creating railings as well. This is a railing that represents a brise soleil shade. So instead of building it inside of as a standalone or a generic model, it's a railing. You just build it by segments. I'm going to create a couple of segments here. The corners don't work pretty well. That's the only drawback, but it does it. I think it does it nicely in curves condition. Texture, rail. Yeah. So this is easy to do. It's easier to do in a railing than it would be with a generic model, and it's very easy to modify. You just sketch the path.
So what would you host that to? Is just a standalone, right?
It's a standalone. It might be hosted about a little piece of floor that represents maybe a beam, or you can just, it could be hosted at a floor with a base offset. This is hosted by level 1. If I want to raise, if I know the bottom is 9 feet, just raise it by that distance.
Yeah, it's pretty neat.
Yeah. Oh, this is the example of the railing that with termination. This is a termination. So, and I think this particular example is an old one. So they may not have terminations. Yeah, this is a legacy one, so it doesn't have the termination ones. But terminations are this type of families that can be. This is a legacy one, so before terminations were available, these were posts. So notice how in this family there's a handrail bracket. So this family is actually this family here. But that's no longer needed. You don't need this. You only need the termination family, and this is an extension post that turns to the wall. Okay, so let me save this file. I'm gonna put it in Google Drive in I'm gonna put it on the railings. I'm gonna create a new folder here called railings and give it 2-3 minutes to synchronize. It should be ready for your use. So the way to use this, you select the railing, copy to the clipboard, switch to your project and paste it. That's the only way to share stair definition, stair and railing definition. Okay, it's 7:15. I think that's it for today. Again, next class, we're going to talk about adaptive components. And I'll have an answer about why the railing didn't spread to fit. And then the state controller is going to be there, trying not to miss the class. It's the last class. So maybe I'm just going to use half the class for the adaptive component demo. We're going to have a data set. And then if you have open Q&A, specific questions about Revit, something that's blocking you on your documentation, like we can use that half of the class for open Q&A. And again, if you know people who is interested in taking this class, send him or her to Lana, because the summer group is forming. So, all right, guys. No more question. I'll let you guys go. See you last class this Thursday.
Thank you, Cesar.
Okay.
All right.
Bye.
Thank you.
Bye-bye.